Okay, so today I'm going to be showing you how to do problem number 11 from the Chapter 5 homework. So the problem asks, a person doing a chin-up weighs 700 newtons, exclusive of the arms. During the first 25 centimeters of the lift, each arm exerts an upward force of 355 newtons on the torso. If the upward movement starts from rest, what is the person's velocity at that point? So first we're going to start off by drawing a diagram. Here's the diagram I drew to represent the motion of the person. So first I drew the person and I labeled that its weight equals 700 newtons. Then I drew here that each arm is exerting a force of 355 newtons upward. Over here, I drew the displacement as 25 centimeters or 0.25 meters because we are going to be using 0.25 meters in our work. And then I also set 0 here and that this is the positive y direction. So the first step is we're going to solve for the mass of the person. So we know that weight equals the mass times the gravitational pull, and we know what his weight is, which is 700 newtons, and we know what the gravitational pull is. So therefore we can set it up in an equation, and then we can solve for m, and we get m is approximately 71.43 kilograms. Then the second part we're going to solve for is this. We're going to solve for the sum of the forces. So we know that the sum of the forces equals the mass times the acceleration. Since we set 0 here, the weight is going to be negative because it's going to be working in the opposite direction. So we get the weight is negative 700 newtons, and then since each arm is exerting a force of 355 newtons upward, we have to add 355 newtons to that twice. And then we also know that it's equal to 71.43 kilograms, which is the mass, times the acceleration. And we're going to be solving for the acceleration. So then we know that the sum of the forces is 10 newtons, and that is equal to 71.43 kilograms times acceleration. And then we get acceleration equals 0.14 meters per second squared, approximately. Then the third part we are going to do is we are going to use kinematics to solve for velocity. So the kinematic equation we are going to be using is final velocity squared equals initial velocity squared plus 2 times the acceleration and displacement in the x direction. So we know that since we started from rest, that the initial velocity is going to be 0. We also know what the acceleration is because we solved for it here, and it's 0.14 meters per second squared. And then we also know the displacement is 0.25 meters because we went a distance of 25 centimeters upwards. Then we can simplify the equation, and we get velocity final squared is equal to 0.07 meters squared per second squared, and then we can take the square root of both sides of the equation in order to get the final velocity, which is 0.265 meters per second squared. And that is the answer.